Okay, here we are for our first body system. Congratulations, you made it through the intro material. And as I said before, from here on out, we're just going to go body system by body system. Our first one is the integumentary system. This is going to include the skin, sweat glands, sebaceous glands. It's really important, even though we don't always think about it as being a body system, but it indeed is. This is also kind of a shorter one, so we're going to ease our way into the body systems. But for sure, they will be getting more difficult and more complex. Well, let's jump into the integumentary system. As I just said, this is our first organ system. So this tends to be a little bit more fun as we get into the organ systems. Okay, here's our picture from the good old movie, There's Something About Mary. So here we have the integumentary system. Make sure you know what it is made up of. In other words, what organs make up the integumentary system? Well, that would be the skin. The skin is in fact an organ. What is an organ? An organ is a collection of tissues. Well, the skin is made up of stratified squamous epithelial tissue. It's made up of some connective tissue. So of course it's an organ, because it's a collection of tissues. So the integumentary system is made up of the skin, which is our body's largest organ, and also some associated accessory organs. These include hair, nails, sweat glands, and sebaceous glands. The main function of this system, probably not surprising to you, is protection. We have to have a really nice barrier or skin between the inside of our body and the outside of our body. There's some other associated functions. It's not just protection. Another example of how this system can function in our body is that it does have a role in helping to regulate body temperature. We know that we have sweat glands that can release water to the surface of our skin. As that water on the surface of our skin evaporates, it has a cooling effect, and that can help lower our body temperature. Really important. Make sure you know the things that are in red and what I'm writing in here. For each part of the system, this is pretty straightforward. You know that you are responsible for knowing the structure and the function. Okay, let's first talk about structure. The outer layer of the skin, let me make that clearer. My apologies. Good. The outer layer from here to here, the outer layer of the skin is called the epidermis. The inner layer is called the dermis. The inner layer is called the dermis. Okay, let's talk about what is made up of, what is included in each. We're going to focus right now only on the epidermis, outermost layer. The epidermis of the skin, I'm going to refresh your memory from our previous chapter. The epidermis of the skin is made up of stratified squamous epithelial tissue, many layers of flat-shaped cells. This is important because this thick tissue is exactly what allows for protection. Now, when we zoom out and we see the whole skin, the dermis is actually a thicker region. So comparatively, the epidermis is a little bit smaller, but this epidermis layer is still going to be 20 to 30 layers of tissue deep. So it's pretty thick still. What gives these skin cells and the stratified squamous tissue, what gives it its toughness is a protein called keratin. So inside all these skin cells in the epidermis, there are proteins called keratin. And that's what gives this outer layer its ability to protect. We also, in this epidermis layer, have some melanin. Melanin is a pigment. And it tends to be in the bottom region, here, or maybe even here, probably better here. In the bottom regions of the epidermis, that's where you're going to find the melanin, or pigment. That pigment serves a function to protect our body from UV rays, and a large part of it is genetic. So the ultimate color of your skin is largely determined by how much melanin and what particular pigment you have. And of course, the overall function of the epidermis is protection. Okay, now we're going to switch gears to the dermis, the thicker bottom region, dermis. The dermis is made up of connective tissue. There is some fat, so if you look down at this yellowish tissue, that's adipose. So we do have some connective tissue, which includes adipose. There's actually another type called dense irregular connective tissue, but it also includes adipose. Inside this thicker region are all the goodies. So inside this thicker region, we have hair follicles. The bottom part that houses the hair, the base of the hair. We have sweat glands. Sweat glands are, I gotta just think for a second which is which here. Let me go ahead. Yeah. Let's look at this picture. The sweat glands are these curly ones. The sweat glands are the curly ones, whereas the oil or sebaceous glands are a little bit more like this. And the oil glands are directly attached to the hair follicle. So here, our sweat glands are the purple coily things, and the sebaceous or oil glands are the glands that are connected right to the hair follicle and the hair. In this dermis region, we also have blood vessels. Some down here that are really big, smaller ones that come up. Remember, it is the connective tissue that supplies blood to the epidermis, remember? Because the epidermis is epithelial tissue. The epithelial tissue itself does not have a blood supply, but it gets its blood supply from the blood vessels underneath. Another word for the oil glands is sebaceous glands, so make sure you review that. So you should know that all these are found in the dermis. And as a result, their functions can be listed by identifying what's in there. So we have the blood supply, that's a function. We have the oil glands, well, they secrete oil. We have the sweat glands, well, they secrete the water that can help with temperature regulation. And what we'll talk about in a minute is the hair follicles and the hair. Hairs are actually there for some form of protection. All right, good stuff. Here's a bigger picture if you'd like. What about those accessory organs? Well, our hair and nails. I think nails we understand. Nails are harder regions over our fingertips and right above our toes. These are areas that get a lot of friction and a lot of involvement and getting bumped and everything, so we want to have protection. Hair's an interesting thing. You know, we don't really think about hair that much, but most of our hair is actually on the surface of our skin. Even if you have long hair, you probably have more hair comparatively on the surface of your skin. Don't forget, every area of your skin has hair. That adds up. But they play a protectory role. You know, what if a little insect, if I could draw, I would draw an insect, but I really can't. What if a mosquito flies near or tries to land on your skin? Well, your hairs are going to sense that. Maybe the mosquito lands right on the hair. and the hair bends or moves. And that movement tells the hair follicle down below, hey, there's been movement. And then a nerve impulse is going to go up and out to your brain. And as a result, you may pull your hand away to get the mosquito off of it. So it does serve a form of protection, mostly from alerting us to the presence of things on or near our skin that could be dangerous. The oil glands, as we said, are these little squiggly things. They produce oil. Another word for oil is sebum. That's where we get the name sebaceous glands, because they secrete oil or sebum. That oil is secreted right along the hair. And it's a nice way to get that oil up to the surface of our skin. We want our epidermis to be a little bit oily, not a whole lot. But think about it. If we didn't have any lubricant, the epidermis could be flaky and dry, and that is not going to be the best scenario for strength and resiliency. So the best situation is that we have that strong tissue for protection, and we have a little bit of oil to keep it from becoming dry. It keeps the epidermis a little bit more pliable. So in that way, not only is the oil a protectant, but it is a lubricator. Lastly, we have the sweat glands. We know what they do. They secrete sweat, which goes up to the surface of the skin, and we release water, which evaporates off the skin, has a cooling effect. Good stuff. Ooh, okay. So that's the basic structure of the skin. I mean, pretty basic. The rest of this chapter, I wanted to put some more practical applications. So we'll talk about some skin conditions, what different skin cancers might look like, and some things about burns. Of course, we could talk so much about this. I am not going to ask you to know everything. Far from it. But I do want to go through a couple things, and I'll tell you what you need to know. Okay. Skin conditions. I mean, we can have shingles, we can have dermatitis, we can have impetigo, we can have ringworm, we can have a whole jock itch, we can have a whole bunch of things, right? And the key as a healthcare practitioner, in order to figure out how to treat it, the key is really determining what is the cause. And really, a skin condition can only be caused by a couple things. It is either an infection, like a dermatitis, something that is caused by bacteria, or viruses, or a fungus. And once you identify what its cause is, then it'll be much easier to treat it, because then you can give an antibiotic or an antiviral or a fungal cream, right? I'd like you to know what is starred. These are common things. A contact dermatitis would fall under an infection. I mean, I've certainly seen this as an athlete. I think about like soccer preseason, and you're not used to wearing shin guards, and all of a sudden you put shin guards over your shins, and you got socks over top, and you're sweating. And that new friction against the skin can lead to basically a rash. So if you see a rash that is there and it is associated with something new, it could be some kind of friction, like I just gave the example with the shin guards. It could be that you used a new laundry detergent and maybe your skin is sensitive to one of the chemicals in it. It's basically a minor allergic reaction. A little itchy, a little red. But if it is in fact contact dermatitis, it's not serious. Best thing to do is just to remove the stimulus or the friction that is causing it. You don't need to know the other two. These are just extra. A decubitus ulcer is basically a bed sore. So if you have someone living in a hospital setting for a period of time and they don't move very much, they're going to have a lot of weight on their body weight on certain pressure points of the skin. By the way, an ulcer is just when the skin wears away. So there's other types. There's a peptic ulcer where the tissue wears away that lines your esophagus. A decubitus ulcer is where the skin wears away due to constant pressure. And it usually leads to a drop in blood supply. You don't need to know this, but I'm just showing you. Psoriasis, you don't need to know. This is usually an infection or a low immune response. Instead of being more of a red, itchy rash, they'll just be like bumps or scales. So you only have to know what is starred, right? So contact dermatitis is starred. I've given you an example of some bacterial infections. As you can see, none of these are starred, so you don't need to know them for a test. Some of these words are kind of fun. Furunculosis, fancy word for a boil. That's really an infection of a hair follicle. Starts off small, but these can actually be pretty bad. A carbuncle is just a boil that is bigger and deeper. Maybe you've heard of impetigo. I don't know why, that's how I pronounce it. I think some people do. Impetigo. The key here is that it is bacteria caused. It looks kind of like a honey-colored crust, small vesicles. I've seen it. I used to cover wrestling as an athletic trainer. No matter how well we clean the mats between practices, or no matter how clean the guys were, and there was a couple ladies actually also, if we just got one little bacteria of impetigo, it would spread very quickly. And there was that honey-colored pustule, and there might be a little bit of a seeping. Folliculitis is just the plain old inflammation of a hair follicle, not an infection like a boil. Acne. This is basically the inflammation of the oil gland. You don't need to know any of these because they're not starred, just giving you some background info. I would like you to know our bacterial friend, well, not really, MRSA. Hopefully you've heard of this by now. This is an example of a antibiotic resistant bacteria. So what happens is, as medicine has evolved and we've developed antibiotics, which by the way is great. There's so many stories from history, Calvin Coolidge, one of our former presidents. This is totally random. One of our former presidents, Calvin Coolidge, his son died from an infection on his foot that he got from a scratch from playing tennis. There were many times in our country's and world's history where a small scratch that led to a big infection could become fatal. We didn't have antibiotics, so a bacteria that got in there was kind of allowed to just fester. Now we have antibiotics, right? But what happens over time is that over the decades that we've been using antibiotics, the bacteria mutate. Over time, they see, oh, wait a minute, this antibiotic, well, I want to do something to get around that. So there's slight adaptations in the evolution of bacteria, and they can become resistant. This is exactly what MRSA is. It's a strand of bacteria that has become resistant to many commonly used antibiotics. So that's the point I'd like to make, that these are resistant, and that's why they're so dangerous. Other bacterial infections, we can just give an antibiotic, but these are much more difficult to treat and much more dangerous. We switch over to virals. One example of a viral skin infection is herpes. There's actually different types. You might think of the genital type, but there's also so many more. You could have a cold sore. That's a type of herpes. You could have it on your face, like a herpes simplex, or you could have shingles. Shingles tends to result in really painful and itchy pustules along diagonals in your back and your abdomen. Warts. As an athlete, I've had a plantar wart a couple times, little wart on the bottom of my foot, and boy, are they a pain. Well, they're viral. Then we can have some fungal infections. I've given you one example to know, and that is athlete's foot from repeated moisture. So we have the perfect environment for fungus, dark and moist. Maybe you've heard of ringworm. That's a fungal infection. Just know the one that's circled. Okay. So before we go on, again, you just needed to know the ones that I had a star beside, and I just wanted to bring up that the biggest part of treating someone that has a skin condition is to identify what it is, because then you can give the appropriate treatment. Maybe it will be an antibiotic, maybe it will be an antiviral, etc. I want to talk briefly about skin cancer, one of the most preventable types of cancers out there. We have three major types. We're going to talk about melanoma. These are the other types that you don't need to know. Basal cell involves the bottom cells of the epidermis. This is the least malignant, which means it is the least likely to spread to other areas of the body. This red bump on the guy's nose is an example of basal cell carcinoma. Then there's squamous cell. Again, you don't need to know it. This is a cancer of the cells closer to the surface of the epidermis. The basal cells are at the bottom of the epidermal layer. This type of cancer would involve skin cells closer to the surface. It looks a little bit more scaly. Again, if caught early, can absolutely be treated. These two, what they have in common is that they look a little bit reddish. Well, that's different from the melanoma. This is the most dangerous type of skin cancer because it is the most likely to spread. As the name suggests, this cancer affects the melanocytes, the cells that produce that melanin pigment. These are easier to spot because it looks really dark. It might start off as what appears to be a birthmark. Sometimes dark marks like that are just that, birthmarks. But if it grows, if it becomes uncomfortable, if the borders are irregular, these are all signs that it might be a melanoma. In fact, you don't have to know these, but I'm just giving a little tool. In fact, one way to remember what to look for, ABCD. If it's a blotch or black spot, are the sides symmetrical? If they are asymmetrical, more likely it's melanoma. Is the border irregular? So look around the outer edge. Is it irregular? Yes. Here it goes up, then it goes down, then it goes up. If it's irregular, that's more likely to be a melanoma. Color. The darker the color, usually the more serious. This picture of the toe is pretty darn dark. So usually the darker the spot, the more likely that it's melanoma. And then diameter. As it gets bigger and bigger, there's a point where, it becomes too big. But these would be the things to look for. I'm not going to ask you this specifically, just giving you the info. Briefly here, we can talk about burns. This is something that I venture to say many of you EMTs, paramedics out there have probably seen, unfortunately. The easiest way to classify is the good old-fashioned first, second, and third degree, more of a superficial first degree, along a spectrum going to the most deep and dangerous, the third degree. We can now apply these levels of burn to our knowledge of the anatomy. The first degree burn tends to involve the epidermis only. It does not involve the dermis. Therefore, it's the least dangerous. It'll look like some redness, like a sunburn. Second degree, now we've burned through the epidermis and parts of the dermis. Usually with a second degree, we start to see some blisters. It's worse. And of course, the worst of all of them is a third degree, which goes through all of the epidermis and all of the dermis. You might see this presenting as really dark red. You might see it as presenting as black, whole host of things. Sometimes there might be no pain because the burn has gone through even all of the pain receptors. Here are some examples to show you. There's a rule of 9s that you may know about. You don't need to know this either. But if you've ever wondered, or, how does a EMT or paramedic, how are they able to estimate how much of a body is burned so quickly? Well, we can use a rule of 9s. So if one arm is burned, I could say, about 4.5 of their entire body surface area is burned. So it gives us a way. And this is called rules of 9 because they're increments of 9. So 4.5 plus 4.5 is 9. So if both arms are really burned, we could estimate that 9% of the whole body is burned. Okay. Some things that can be done to treat it. Not going to ask you this, just some cool pictures. If there's a really big spot that's been burned, oh man, what if they're burned right there? One thing we can do is if it's bad enough, we can, I'm waiting. We can do a skin graft. We can take a piece of skin from somewhere else. Take a piece of skin from the gluteal area, inside of the thigh, where it's not going to be as easily seen and where else it'll grow back. The tool that is used to take off the piece of skin to be used as the graft almost looks like a cheese grater. Ooh. And then we place the skin from somewhere else in the body into that burned area, hoping that the person's skin below, what's left of it, will grow into the skin graft. On the left might be an initial look at a skin graft, and then on the right, after it's been healed for a long time. If you're wondering why they have little holes in it, it's because the skin underneath needs air. That's one of the ingredients it needs to fix itself. So we do open ourselves up to a little bit more infection, but it's important that it's open to let the tissue breathe and grow. All right, last 2 questions. These 2 I'd like you to know. You probably already know these. This is what I've read and what I've gone by in my professional career. How do you know when someone needs stitches? Well, usually people will say, oh my God, how deep the cut is. That is one part of it, but it's not just the depth. What about the width? You have a tissue that's been cut. If it's not that wide, I can just bring the 2 edges together. I don't need stitches. But on the other hand, it could be not very deep, but it could be wide. And I need help to bring those 2 ends of the tissue together through stitches. So the important thing would be to look at width. Depth is somewhat important, but not as important as width. You could also look at where it took place. If I'm already in the middle, hold on, let me take that. I don't know where my mind is today. If I get a cut on a place that's very open to see, so if you get a cut on your face, you probably would be more likely to want to get stitches to avoid having a scar. Where if I have that same depth and width of a cut on my inner thigh, I might be less likely to go for stitches because I don't care if it heals a little bit wonky. And then, what do you do with a blister? Do you pop it? My suggestion has always been absolutely not. If you have a blister, sometimes you can lance it, poke a little hole in it with a sterile needle just to get some of the juices out, but you want to avoid taking the front flap of skin off if possible. So, as we said, stitches, width is probably the most important. Also to consider would be depth and location. Blisters, lancing is the fancy word for poking a hole and squeezing out some of the juice. Try and keep it if you can. All right, well done. First body system already over with.